Hey guys, it's Zach with Aldec, and welcome to this ALINT-PRO tutorial. Today we're going to use features in ALINT-PRO to check Xilinx ISE designs. Some FPGA projects, especially in defense, are version locked and must use older Xilinx chip families along with Xilinx ISE as their design environment. Now, compared to Vivado, ISE has even more limited verification capabilities. Of course, many errors can be caught after synthesis, implementation, or in lab, but that requires long iterations to identify an issue, trace that to a root cause, correct a code, and then rerun all implementation phases again. Linting and CDC tools like Aldec's ALINT-PRO could be useful to prevent mistakes in early design stages. For this example, we're going to take a look at a basic ISE WaveGen template. We'll notice that this design has 3-core generator IP blocks, FIFO, memory, and clocking wizard. To prepare the design for ALINT-PRO, we'll run synthesis in ISE. Once synthesis is completed, you'll be able to move into ALINT-PRO. But first, let's take a look at the IP blocks shown in the RTL schematic. Once open, we'll be able to find the FIFO, and then the memory, and finally the clocking wizard. We'll be able to recreate a similar schematic in ALINT-PRO, so let's move into ALINT-PRO. In the file browser, we can navigate to the directory that our ISE project exists in, where we'll be able to import the ISE project file with the .xise extension. We can double-click the project and the tool will open a Convert XISE project wizard. Notice where there's an option to overwrite existing files. If you will be importing this project a few times, selecting Overwrite Existing Files will cause all linting settings to be lost. Linting settings will be automatically kept for the same project through multiple imports, so only use this if you wish to erase your linting settings. Click Next and you'll be able to view the resultant workspace structure after import, and then you can click Finish. Importing the design will automatically separate the IP in the design from the rest of the design files. Once the tool finishes importing the design, we are redirected to the project manager, where we can examine the imported design structure. The main parts of the design can be found in this default design space. We have the imported IP files and then the rest of the design files. We can see the FIFO, clock core, and memory. We should also look at the Verilog parse preferences for the design. We can see ALINT-PRO has automatically bound the necessary Xilinx primitive libraries. Also, if we look at Library Viewer, the Xilinx ISE library was set automatically and was attached. Using the ALINT-PRO import method prevents the user from having to set up the project, which saves time from arranging the project and its settings and resolving any errors that would be encountered during that step. Now let's go ahead and run the design. Once the tool has finished running, we go to Project Run Success message in the console, along with a few details about warnings and violations. What we'd like to do is move into the ALINT-PRO schematic viewer to see how ALINT-PRO interprets and understands the project. We can see the memory IP block, the FIFO IP block, and the clock core IP block, which is in the clock generator. Exploring further, we can see the tool is able to properly understand FPGA primitives and their pins, such as clock or reset. With no manual effort from the user, the tool interprets these correctly from a CDC point of view. The models and rules understand the meaning of each primitive pin automatically. However, linting and CDC do require different library models than simulation, and there is an important distinction to make concerning library handling between simulation tools and ALINT-PRO. Simulation-targeted libraries are non-synthesizable and act as a behavioral or timing model. Linting only utilizes the I/O pin definitions, and the body is replaced by a high-level model based on block-level constraints. You can learn more about these constraints files in the block-level design constraints tutorial video. But this is why you should not compile vendor libraries. Instead, reference pre-built ALINT-PRO vendor libraries. ALINT-PRO library versions match the latest versions available at the point of release, and I/O pins are backward compatible between versions. Therefore, there is no reason to downgrade if using an older version of ISE. Also, there is no current support to work with UCF constraints. It is best practice to create a chip-level Aldec design constraint file and bring over the necessary constraints. You can check out our tutorial video on chip-level design constraints to learn how to create or automatically generate constraints. Keep in mind this step would be for advanced or non-obvious cases when linting a design. Automatic detection of clocks, resets, and I/O delays works fine in most simple cases. Well, that's it for this tutorial on checking Xilinx ISE designs in ALINT-PRO. Thanks for watching.